Dr. for the kind introduction, and thanks for inviting me. For being here. Yesterday we heard all about how NLP inform linguistics, and today I want to tell you about how linguistics can inform NLP, and more specifically a sub-area of linguistics called linguistic typology. Now, I like to start my talk with some good news. There's clearly the field of NLP has had a very strong focus on using English as the main language of investigation, and there's a wave that's starting to change that. And there's a clear increase in interest in multilingual solutions, and a new community has emerged that's calling itself multilingual NLP. Now, but there's a but. It's still the case today, in spite of this enthusiasm and progress, that access to language technology is highly unequal. And I like this figure to really make this point. This figure represents the performance of a specific type of NLP system, a named entity recognition system, and the bars on this chart represent the languages. And their width represents the percentage of the world population that speaks them. And that allows us to see that for almost half of the world languages, we simply do not have any named entity recognition system. And for an additional about 20%, maybe, we have systems that perform with an accuracy below 60%. So that makes these tools not really very useful in practice. And we can clearly see this divide with a minority of languages that have state-of-the-art solutions for this specific task. And actually, the specific task, if you compare it to other tasks, it's actually painting a rather good picture. For other tasks, the situation is even worse. So there might be an impression that there's progress, but remember that NLP has made enormous progress in the last few years for English, and we're not seeing this progress in other languages. So essentially, the gap keeps increasing. And of course, because, and that's what I'm telling you about, we don't have enough data for English. So this problem is not going to grow. And this is certainly true. Is this better? Yeah, okay. I'll just use this. Since this is also not sure. It's very clear that there's a problem of data availability, but I'm going to claim today that the multilingual NLP paradigm is actually English-centric. We have this great community doing multilingual NLP, but we're still being very English-centric in how we go about tackling multilinguality. And so this issue is that amplify the inequality in data availability. So the solution to this problem I'm going to play today is that we have to do NLP in a completely different way. We have to completely revise our evaluation, but also experimental design protocol to account for that. And multilinguality really has been at the periphery since we started hearing about it, even more before that. And I want to think of ways to put it at the core. Now, in many of my recent talks, this is how I concluded it, and it sounds like streaming into the void a little bit. Why is that? Because actually the ingredients for doing that were missing. And what I want to tell you today is that we actually have ingredients necessary to actually go about and do this kind of change in the way we work. And I'm going to highlight in this talk the central role that typology has to play. And this is essential to say, especially in this community, why am I talking about general NLP model developers to a rather linguistically oriented audience? It's because I believe and I'll show that the community is sometimes a little bit naive when it comes to typology. And so I believe that this community here has a lot to teach the general NLP community, and that I think we have a central play in revisiting this NLP pipeline. So let me start by characterizing a little bit more what I mean by the fact that multilingual NLP is English-centered. How do we work in NLP generally? First, we put a lot of effort in developing language models for English. And this is illustrated here with a language model everyone involved in this has heard of, but this is also true for the new models. Engineers and companies put a lot of engineering efforts into developing a model. And language models are really the backbone of all of our NLP systems. So really it's central to what we're doing. And then what happens when we work with other languages, we just take these vanilla models and we do not really adapt them much, make really minor modifications and apply them to other languages. And you might notice that the languages which we have decent, they're all high resource, right? So what do we do about other languages? Well, we tend to just lump them together into one giant model. And so the Edward model has been popular, and we're hearing about it in the talks in this conference. Edward is essentially a word model trained on the concatenation of Wikipedias in 100 languages. So we put all of these languages together. What do we do next? We evaluate this model by using datasets and metrics that are biased. And I'll explain this a little bit more at the end of this talk, but what's important to know at this point is that typically our datasets are taken from English and translated into other languages. And then scores are averages across a biased selection of languages, and worst of all, in the extreme case of the extreme popular benchmark, which is a collection of existing datasets, we're actually averaging these averages across a class. So you have one number that is telling you how good your model is, and it's supposed to summarize tasks and languages. So obviously this is wrong, and to be fair to the extreme authors, they kind of redeemed themselves from that in the later version of extreme. But just the fact that this has actually been used by researchers highlights the problems that this community is facing. So to sum up, the problem then is that design choices are made for English and they are never revisited. And these choices might be suboptimal for other languages. And I'll show an example of that in a moment. But for benchmarks, they don't allow us to identify that because we have one score summarizing the performance of our language models across tasks and languages. So let's take an example. What is the main units of processing used in language modeling? Historically, NLP worked for a long time with orthographic words. And this works quite well for English. If you use white space to split the sentence, you're working with units that are useful to work with. Language models tend to work by looking at occurrences of words in the corpus. And if you look at the occurrence of the word, for example, English in the corpus, if you look at all of its occurrences, you'll probably get a decent representation of that word. Now, first, when you're facing Chinese, I don't speak Chinese, what this is supposed to say, it's right. Of course, orthographic words fail. But also for languages that have more morphology or that allow, for example, noun compounding, you probably also don't want to use an orthographic word as a basic unit. Because if you're trying to represent the words made when it is written and also which is Dutch for employee satisfaction survey, only by looking at the occurrences of this exact word in your corpus, you're not going to get very much information. If you're allowed to split it in memory, satisfaction, and survey, you're going to be able to get something more useful. Now you're going to tell me nobody works with words anymore. The de facto standard current NLP system is to make use of subwords. Now, if we look at what subword organization looks like in practice, for example, this is our GPT for to organize English. It looks like the units are meaningful. I still don't speak Chinese, so I can't comment on how GPT organizes Chinese, but I can comment on how it organizes Dutch, and it's pretty bad. The units break morphological boundaries, and for example, the unit solver really does not make any kind of sense. Now, why is this happening? It's because subword units are units that are determined based only on frequency of per characters. They are not even trying to be linguistically meaningful. And empirically, they're being found to work quite well for English. But if you work with other languages, for example, that are morphologically complex, researchers doing that have found this to be problematic. So subword units may not be the best units of representation if you're building multilingual language samples of languages that have complex morphology, and they may also not be the best units to work with for multilingual languages. But I'll come back to all of this. So to sum up the story so far, the design choices for language models, monolingual, multilingual, are largely based on English, and it's amplifying the issue of data imbalance. And I want to argue that we should design choices for language models should be informed by the typological properties of the languages being modeled. Now, how do we do that? Realistically, we cannot build language models for the estimated around 7,000 languages. So everyone estimates there are 7,000 languages. First of all, because we don't have the data for it, but even if we did, for compute reasons, we cannot meaningfully do like development on so many languages. They're just for a compute perspective and also for a journal analysis. It's going to be too complicated. So we need a way of sampling languages. And that's one of the ingredients that we've been working on that I'm going to present next, that allow you to sampling in a way that is informed by typology. So how does this sampling work? We recently got our paper accepted by the Computational Linguistics Journal, but we've had a preprint out there for a while, so you might have run across this paper where we propose, want to take a picture of it? Where we propose, so based on some sampling frame, which includes the languages for which we have data, we represent each language in the frame by a vector that represents the language. And how do we get this vector? We can use, for example, typological database. We heard this about walls, Serial, Grandband. In this work, we used Grandband, but really, you can use any kind of representation that you want. You can also use a geographic representation if that's relevant to what you're trying to do. So then you have a feature vector that represents the typological characteristics of your language. And based on that, you can then measure pair distances between all of the languages in your frame. And based on these pair distances, we develop algorithms that select a sample within this frame that maximizes the diversity. We developed two sampling algorithms, so this is also with the help of colleagues from Leuven University. One maximizes the sum of distances between all points in the set, and it can be visualized like in this figure where red dots are so this is like a scale plot presenting the languages into dimensions, and we can see the red dots are the languages being sampled, and the blue dots the languages that remain in the frame. And maxmin, by contrast, maximizes the smallest distance between any two points in the set. And the result was different. The result is something that's maximally independent. Previous one is maximally diverse. And we found that both of the samples so we construct the samples with 20 languages and compared them to baselines, and we found that they perform better on 4 diverse metrics. And we also found that it matches downstream. So this figure here, a little complex around human fluids, represents accuracy distributions of language models fine-tuned for the top classification task of taxi 1500, which is based on the binary. So this is results for constants and languages. And we found that the accuracy distributions of the 20 languages that we sampled looks much more like the accuracy distribution of all the languages. So our samples are origin, and you can see that it looks much more like the green, which is for all languages, than the convenience sampling, which is our baseline. And you can see that the convenience sampling clearly overestimates the accuracy of our model. Now you want to ask, okay, great, what are those baselines you're talking about? Essentially, they're samples are representative of what the community in NLP is currently doing. And how do we find that out? This is the result of another paper where we surveyed the community to find out what the community means by the phrase typological diversity. And the motivation was that we kept reading papers, and to be honest, writing papers that included this kind of sentence. We're working on 9 typologically diverse languages. We're working on 8 typologically diverse languages. And these are the languages. Yeah. Notice something? Very Eurocentric, Eurocentric. This is maybe a little better, but still not ideal. So we asked, what does a community mean when they say typologically diverse? And we found we looked at all the papers that included this and related phrases in the ACLM talk and some machine learning conferences, and found that it's largely inconsistent. We asked, how do people justify this language selection? How do people decide on which languages to include in their sample, including often quite vague. This is an example of a paper that says they're including 24 languages in different languages, covering a reasonable variety of language families. What is reasonable? And then I really like this one, they included language different syntactic properties like word order. And I really like this sample because it has 9 languages, 2 are not Indo-European, and 4 are actually Romans. And this paper won the best paper award in 2019. And I don't want to blame the student for that paper, I want to blame the community for letting this slip. This is the best we can do as a community? I don't think so. So the last question that we asked in the paper, are the samples the community is using actually diverse? And we found that some are better than others, but there's a clear European skew. And this is illustrated quite well by this other student who wrote something in 5 pages. They're working on their statements, English, French, and Spanish. Again, not blaming the student, blaming the computer system that let this kind of sentence maybe to our talk to the conferences. There is something wrong. So to sum up, I argue that design should sum up this section, don't worry, design choices in NLP should be informed by typology, and we need to evaluate models of typology in diverse languages. And the community is aware of this. They're really trying to say, oh, you can do typology in diverse languages, but largely unsystematic, sometimes a little naive. and the samples that they use that not actually be typologically diverse. And we can use our sampling framework better, and I think we can also use the input for the stability to do even better. But how? I'm going to ask. It's not so simple, right? Ideally, we should start always doing model development on English first and other languages next. We should do model development on a sample of typologically diverse languages. Then we should evaluate on our models on languages unseen at development time. And here, I don't mean we train a model on, say, French and test it on German. I mean, we train a model on French, and then we do the model development, and then we see if we can also train this model on German and get similar accuracy. And apologies for starting, just obviously not great. But we get that, I think. And this is a very old idea. To my knowledge, this was first proposed by Miryam de Lhoneux more than a decade ago, and to my knowledge, it's actually never put into practice. Partially why? Because we, again, haven't had the ingredients until now, and the sampling framework can actually allow for this. So we can extend, and this is work in progress. We haven't completely worked that out, so your input for this would be really relevant here if you're interested. We can extend our sampling framework to construct disjoint samples of development and held-down languages. So this will allow for what the top part of the slide says. And we can do this. That's, again, work in progress, not published at all yet. We're thinking about this. We can, for example, run our sampling outline in alternating terms, where we assign a development language first, and the next is held out language will be continued. There might be other better ways to do this. So that's something to think about in the future. But realistically, when we ever do model development, right, especially in academic time, people who do model development, they work at Google, they have a lot of compute. So realistically, these people have to talk to, and the chance that they listen to this is relatively low because of the economic impact of this. So, okay, what can we do? We're not going to start NLP from scratch, right? We're not going to ignore that we ever had models. We have to start somewhere. I still argue that this ideal approach can be used if we have an entirely new model design. Say if someone decided that maybe working with pixel language modeling would work better, for example, use this. Yes, this is another slide myself. But what can we do with existing models that are there? And I want to argue to study the interaction between design choices and typological properties. And so we can revisit some of the design choices post-hoc, essentially. And for this, we need to bring back what I once called the multilingual experimental setting. The word never got questioned again because it's not a great word. Happy to hear other suggestions, but also because the setting simply kind of disappeared from the practice. Most people, I introduced terminology to differentiate between when you're training one model and applying it to other languages, from the case where you use one model of architecture, but you're training multilingual models for each of these languages. And very few people do that nowadays. They do that, they use a multilingual model as the backbone. So I think we should further split this terminology to include for that case. But so there are basically no videos that take monolingual language and monolingual fine-tuning data. So we need to bring this back. Now you're going to tell me, but that's great. And how are we going to train it transform? language that has very little data. This is the maximum where people have practiced and completely fit it. Well, actually, this is the biggest piece of good to share with you today. This has become possible very recently. The goldfish paper is a preprint, to my knowledge, still not published. They trained a suite of language models for 350 languages. Now, this is only partially good news. These language models do fare better than multilingual ones for some intrinsic metrics that are themselves kind of questionable. So, okay, maybe not great. And they're doing worse than multilingual models in recent benchmarks. So maybe not so great. But in our group, we've actually found that we can train small transformers on small amounts of data, and with some quantity filtering, here we work with Wikipedia data, which is problematic for a lot of languages. With some quantity filtering, it does better than multilingual language models, even if you do quantity filtering on these multilingual atoms as well. So we can actually study the interaction between typological properties and language models. And we did this recently, so we've been practicing what we were preaching, putting our mind where our mouth is, and actually went ahead and studied the interaction between one specific typological characteristic, morphological complexity, and its related order flexibility, and we integrated with one specific type of sectors, positional embeddings. And what position embeddings? Position embeddings are essentially the only way a word model knows anything about the order of words in a sentence. If you exclude position embeddings, what you have is essentially a value of very fancy words model. So we ask the natural question, are position embeddings also more useful for languages that have more fixed word order than languages that have free word order? And we used our sampling framework to select several languages based on features that have something to do with our question here, right? We'll work with from grammar. And here we decided on the 7 number by looking at the feature value inclusion. So we noticed that if we include 7 languages, we have all of the features that we want. So this seemed like a good number. Now, just a little spoiler, it doesn't really matter for the spark, it's a little spoiler, we didn't find clear correlations. Positional encoding seemed to be important for syntactic modeling regardless of the language, and less important for topic classification. So they are important more on the task perspective than the language perspective. This is maybe bad news or down news, what I've been saying, that we should take into account typological profiles, but I do think this was just the first step, and we need to do many more such studies to study many more design choices and revisit them. Here it seems not super necessary to revisit this specific choice, but there might be other choices that we want to revisit in the light of these results and these correlations that we might find with typological properties. And we have an upcoming project, it hasn't started, we've done the hiring, so we're going to start soon. Joint project with Lisa Owen from the University of Göttingen, where we want to apply this type of studies and investigate what is the best unit of representation in multilingual language modeling. I'm saying this just to say, look out for this work. I hope that this will lead to interesting results. But also, if you're interested in collaborating, I can fund it because the money is accounted for, but I'm happy to talk about collaborating this project, which has not started yet. So just some of the stories so far, what I've tried to demonstrate is that with typologically diverse sampling and language models that really seem to be possible to train on small amounts of data, so we can actually do language models for languages where we have very little data. We can study the interaction between language models language modeling design choices, and typological characteristics. And we hope that this can inform future development of language models. We can do multilingual models that are more adapted to the typological characteristics of individual languages instead of just relying on English, but also multilingual models that hopefully work better for both languages. And they are not based only on the characteristics of English. Now, in this final section, I would say that the catch. Language sampling does not solve the initial problem I talked about, the data availability. And this is illustrated by our bias from the study I just presented. There's still an European bias, which is due to the availability constraints, right? We just cannot use data that we don't have. And so this is what I want to, in this last section, talk about available question marks and what we can do with them. So I must mention this extreme benchmark, which is a collection of existing benchmarks. And it's really used quite a lot in multilingual NLP papers. And if we look at the dataset that it uses, it relies quite a lot on what I said earlier, on using translation of English data into other languages. For datasets for which it doesn't do that, we have, for example, NER, which uses automatic annotation. So Wikia is somewhat noisy dataset. Typologically is better, but yeah, if it doesn't include so many languages, then there's often datasets that rely on parallel data. Here they're always aligned to English, so there's still clearly some English centricity here. And we have a, I would say, quite unique dataset at our disposal, universal dependencies, where we have independent annotations of data occurring naturally in the languages for many languages. So I think really it's very unique in the space of multilingual datasets, and we should use it more in multilingual NLP. Now, just to mention the quite egregious fact about this extreme benchmark, they don't have data for all the pastoral languages. What they do is they just take English, automatically translate it to the other languages. Now, this is a hill I will die on, and I don't need to spend too much time on this, but if you want to create data using machine translation, okay, maybe acceptable, but using that for evaluation, please don't. But I guess you're wrong on this. Now, there are other possible multilingual datasets beyond Extreme that are not included in this, which we've also been using with our group. They're great, they cover quite a lot of languages. They still have this issue that they're relying on parallel data, where the English side has been annotated, and then the annotation has been projected onto the other languages. So they're still really English-centric. Now, better datasets have started popping up. There's the Masakane community that has been developing these datasets. And these are great. They're again independently annotated in all of these languages, so they're really useful. They still cover not so many languages, so it's workable, but it's still there's no clear thing of trying to represent your languages. Rather, they're filling and matching the gaps. Still, I haven't run the numbers, but I wouldn't be surprised if some of these were actually more typologically diverse than some of the typologically diverse sets that are out there. So I think these are really good datasets to use, and I think we should use them more. Now, if you ask, this is all natural language understanding. Does that these days? We've moved on to automatic methods. And we're really, the community is much more interested in natural language generation. The story is not there, it's probably worse there. As neatly summarized in this paper from this, so this is a preprint recently posted, it surveyed evaluation in multilingual natural language generation. and just summarizes the datasets that are available. And there are only 4 of these that actually do not rely on translating the original English benchmark, and yeah, they don't cover so many languages. Still, it's somewhat usable. But there's another issue with evaluation of multilingual natural language generation, is that it tends to rely on English prompts. So, for example, this is an example of a prompt from an existing dataset that says, please translate the following sentence from German to Dutch to give me half the case. And in this recent data paper, we argue that this is not measuring what is claimed to measure. We're not only measuring how well a language model can translate from German to Dutch, we're also measuring how well it understands English instruction. So overall, I want to highlight in this section that in most dependencies is really unique. It's a dataset that's based on authentic data, independently annotated, that covers the largest number of languages. And really it has a role to play in establishing best practices in this revisited multilingual NLP paradigm. So I have invited to start finding you a program of NLP. I think we have a lot to offer to kind of change this mindset of multilingual NLP and make things better down the line. To summarize this talk, I've argued that NLP is English-centric, multilinguality is at the periphery, and then it amplifies the inequality in access to language technology. I've argued that we need to put multilinguality at the core of what we do and show some ways in which we can do that, with the need for typology, and show how the community is aware of this, but it's really unsystematic. With typology to their sampling, we can study the interaction between typology and design choices, and ultimately hopefully develop models that are informed by typology. And finally, I emphasize how English-centric multilingual datasets are, saying Unity is the best we have, and that it has a central role to play in this revisited paradigm. To finish up, I want to thank my amazing at Leuven. I have 3 amazing PhD students that have really reshaped some of my thinking around this topic. In particular, Mr. Leuven has been involved in basically all the work I've presented today. Of course, as a leader in Spirova, I have engaged directly in the typology data sampling, and I've thought about this question also with my PI on the upcoming project with a board. And I see the role of SyntaxFest into myself. Thank you.
That's a unit of representation. You make the point that it may not be the word. So if it's not the word, is it a morpheme? What is that unit? It seems like it's a sort of mysterious unit that more was said about.
Yeah, this is a great question, and we have an entire front that's going to investigate exactly this question. My personal belief is that it's really hard to find a good unit of representation that works. One unit of representation that works across all of the world languages. For English, I believe suburbs are actually quite a good unit to work with. They've empirically found to work well. There's work trying to inform suburb units with morphology, and it needs some improvements. So yes, morphology can where suburb units can be a better representation. The downside, of course, is that you have to have access to morphological data sets, right? Which are not always available. But there's other options. You could use formulas. You could use so there's also characters, right? There's some work that I didn't mention today that I think is making the case for characters, and characters can be used for characters can maybe a little bit more fair, but they're not meaningful, right? And they're very different for for example, languages that use no graphic systems compared to alphabets. So I believe that there is no one type of unit of representation that is purely the best. I think it's not language dependent.
And if you for making us believe that there is a future for you being able to great for what I need. I guess this is more of a comment than a question, but one thing that I really like about the sampling work is that it shows that you don't have to evaluate on 100 languages to be typologically relevant. You can actually work on quite small sets, provided that you take this sort of sample and think carefully. And I think that also helps to address another problem, multilinguality, namely that far too often people work on languages that they don't understand. And therefore they have to rely on these automatic evaluations from dubious data sets and get these numbers that make them happy, and they don't realize that the output is actually gibberish. So I was wondering whether you had any comments or additional thoughts on how we can work with that problem.
Yeah.
Obviously, the work that you're doing is already making the suggestion that what can we do in addition?
That's a great question, and deals with stars for sure. Yeah, I think this is something that I go over to start, but I mean the main the big aspect is data quality, right? And I think that the solution is community-based data sets construction, like what Mastercard has been doing, and we need more of that. And what can we do if we're not building that? Yeah, I mean, we've also been investigating data quality, right? There's this, there's also speaking about Google auditing the quality of web data, finding exactly these issues you mentioned. It's not actually that language, it's actually just some random characters. So we need for this, there's no other way to involve with the community, right? And get that data. I don't think we can do much more as a non-figures in these languages.
Just a quick follow-up, you really emphasize the quality of data. And I want to pause the question of situation where you, for reasons, you use translations of evaluation data, but this goes to make mistakes that collect it and make the quality very high in terms of the language itself. So it's in terms of resources that's lower, we can do that in forwards. And asking the question, the quality we're talking about, this question of form, and the language is perfect human level, or is it a question of content? The kind of data that you find, in natural programming environment. Can you maybe be more specific about that?
This is a great question. I'm not really sure. I mean, there are multiple issues with using translation. So when you're saying translation data is usable.
I'm saying you put word the quality and get it the quality in terms of the form of the language.
Yeah, that's. No, I think, there's also really layers in how we use translated data. We automatically translated data for evaluation is no-go. Translation, human validators, yes, okay, that can be useful. It's better if it's culturally sensitive, right? There's also this whole line of work showing, look, you can't translate this concept from English into like strangers into it doesn't make any sense. So let's pick a relevant concept in English. So this is better. So I do think that we can use this data sets. It should just not be the only data set, and we should always use English translations for non-English languages, right? Because in spite of the best intentions and the cultural bias, it's still not going to be data that is naturally occurring in that language. So we need, and this is complementary, right? I'm not saying throw away all translation data. We do use that in our work also. I'm just saying it shouldn't be the only type of data. And that's why I also highlighted how unique we do this.
I wanted to come back to the sampling question, which I think is very much needed. I was wondering whether you had done an evaluation to sample with respect to traditional bundling of languages into families.
Yeah. Yeah, this is what we.
It's also that.
Yeah, so. Sorry. Yeah, this is, I guess, sorry. I also put this table for time reasons, but this is kind of baseline writing family and represent, right? If we take random language, but always changing the language family or the units of the language. This is the direction to get for this number of languages. I don't know what that translation.
Just to make sure I understand. So random or random. Oh, okay. That's the difference between random and family.
Yeah. Thank you.
What about this question?
Thanks. Thank you so much for having me. Thank you so much for talking. Really good. Really kind of bring this as here. I was wondering, so put it down here when you said, we don't know that allows for languages because we don't have data. Not having the data is really practically for not just having different types of language solutions, having links. Some areas will have data if regions are found, some of them don't have data because different locales and access, etc. And some of these more desirable typological languages, the ones that are really different, the data would be there because they were aliens wouldn't want people to play it. Because that was my most beneficial thing to them. I was wondering if doing the work, doing more sampling, etc., you know, come into this topic. How do you think the community sees this kind of political situation, diversity, and some languages don't, the communities would enthusiastically want us, we have some communities who don't want us even data. I was wondering if there's not any work. Well, do you think it should as a community work?
Yeah, thanks. It's a great question that I didn't look about, but there's this one line that's related to what you're saying by Stephen Bird and colleagues, making the case that should look for language equality in terms of language technology access. And for a while, it's really bugged me and made me rethink my research agenda. Are we being colonialists here? And I found an answer, and I think what I'm aiming for is not to build an algorithm for all world languages, because like you're saying, communities might not want that. But rather, I want to push for the field to build models that can not easily build on languages and type of profile. So it should be up to the group for actually building that model. But to push, what I want to push for is that there's much less gap. Once you have the model, when you decide what to build it, there's much less work to be put into for that language. So what we're aiming for, feasibility of developing models.